Hello, my name is Irene Michelle Slusher, and I'm a senior at George Mason University. This is my capstone final project for BIS 490, and this is my proposal presentation. My research proposal examines solar-powered vehicles and their effect on climate reversal and public opinion. This is the Department of Integrative Studies at George Mason University. The interdisciplinary studies include IT security, conflict resolution, and energy. And my instructor, Dr. Kurt Lazaroff, was very, very important in helping me finish this project. We will examine the theory that solar-powered vehicles make a critical difference in climate reversal and public opinion. The final project proposal covers the Internet of Things, conflict resolution, and energy. Here are some terms that the audience might need to know for the presentation. CE is combustion electric hybrid. EV, electric vehicle. PV is photovoltaic vehicle, which is actually all solar. PHEV is a plug-in hybrid electric, and BEV is battery electric. ICE is internal combustion engine. Maglev is magnetic levitation. SEP is solar electric propulsion. DART is double action redirection test. This is the intro. The hypothesis states that solar-powered vehicles will produce a significant reduction of CO2 emissions to reverse climate change. Unexpected elements could be limited range, could not be extended, or unpredictable solar, or no solar at all. Interdisciplinary rationale. This involves IoT, conflict resolution, and energy. In this case, we're reviewing the solar energy. IoT security is critical. Conflict resolution follows. And the energy generated and stored must be green, sustainable, and not geopolitical. Conflict resolution is critical before and after. Solar energy can be stored in batteries or solar cells, or just used directly. IoT must be secure for effective solutions of all of these issues. Literature review. It examines the alternatives, in this case AMV cube cell, retrofits, hydrogen cells, aluminum cells, aluminum batteries, magnetic, and maglev, and it investigates the positive and negative. Here are some alternatives to solar vehicles. AMV cube cell vehicles. They can charge in 15 minutes and have a range of 500 miles. The negative is that you need to plan your stops for charging stations. Retrofit. The positive is that it can be done on an ICE vehicle and convert it to an EV vehicle in one day. The negative is that it has limited range. Hydrogen cells is another alternative. It comes in containers. The negative is that it's flammable and regulated by the government. Additional alternatives include the aluminum air battery vehicle. It can go 1,000 miles, but At that point, when it reaches 1,000 miles, you would have to replace it. Magnetic, as an alternative, there were magnetic hybrid cars in the 1900s. The negative is that they were too expensive compared to ICE vehicles. So may also be the case today. Magnetic levitation or maglev vehicles are autonomous. The negative is you would have to build the infrastructure of magnets in the road, and they're noisy and they could produce radiation. The challenge, or the question that needs to be solved for the solution to the problem, can be unexpected or roadblocks or conflicts. The main one is the range. If you're unable to extend the range competitively with ICE vehicles, or to satisfy the needs of the consumer, then you would have a problem. Unpredictable solar would mean that you would not even be able to use the sun to charge, or some other method to charge that would be a hybrid to the solar. So this is a key issue also. Another question is, the issue is important because all three fields are critical for the advancement of this technology. The advantages are the disciplines in Internet of Things security, which is everywhere now. Solar energy is sustainable and not geopolitical. And conflict resolution, which is necessary for successful solution. On this slide, we will discuss the problems which need to be solved for the future safety of the Earth. Scientists said this is very crucial at this point in time. First, there's pollution. Then there's climate reversal, and then there's geopolitical energy avoidance. Dispersed, decentralized green energy is important. Energy vulnerabilities will cause wars. So all of these problems need to be solved. Methods used in this research are as follows. We will compare current technologies, and we will conclude the best method to expedite the solution. The data analysis, it includes qualitative review of current technologies. The EV and PV or hybrids seem to be the best solution. Since emissions are an important problem that need to be solved, we can use the government app to determine the emissions of any vehicle as a simple way to compare, and very effective. Here are the results and findings of the research. This slide covers solar electric propulsion, and DART is the double action redirection test that was started in November when I was doing my research to divert the path of an asteroid. It's very effective, and we will know in October 2022 what the results of this mission are. The very first solar car was actually too small to drive, but it looks like it's a pretty cute little car, which makes you think that maybe they can make small models solar powered for kids today. But anyway, that was in 1955. And then currently we have solar race cars, which is sponsored by the World Solar Challenge. The first electric car conversion was the 1912 Baker electric hybrid that they converted in 1962. It had 11,000 solar cells on the roof. Electric cars were actually invented in the 1800s. This cost $20,000 in 62, but that would be over $160,000 today dollars. And it only went for 3 hours at 20 miles per hour, so needed some improvement. This is a 1901 loaner Porsche Semper Vivus. It had batteries, but only went a limited distance. But it also had a fuel tank for ice. They had propulsion in the tires. You can see the front tires have motors on them. Eventually they put motors on all 4 tires, and they used this vehicle for racing during that time period. In 1916, a vehicle called the Owens Magnetic was produced, and it created electricity with the magnet. It also had a 6-cylinder engine, but the power was through the wheels based on the electromagnetic transmission. This is the earliest example of an electric series hybrid drivetrain, and most problems with this was that it was so expensive. Only opera stars could own it, or movie stars. Atlas is providing electric AMV cube cell vehicles with the 0 to 100% charging in less than 15 minutes, and comes in 300, 400, and 500 mile range, depending on which you buy. They also produce box trucks and emergency vehicles on their XP platform. This is a Cybertruck from a company called Tesla, and Elon Musk promotes it really well. He's made electric vehicles really popular. He sent a little tweet that said he thinks it can, that the added solar power can generate an extra 15 miles a day, possibly more, and they might add solar wings that could generate 30 or 40 miles a day. So this is an option now on the Cybertruck. This is a vehicle called the Squad. I would refer to this as a light solar car because there's only room for 2 people, but you can fit 4 of these in a regular parking space. You can have grid charging or roof solar that adds 20% to the range, and it has smaller batteries that are replaceable for a range of 25 miles. This is great for smart cities. It doesn't require a driver's license or a helmet, and you have no parking fee, so basically provides free solar to the consumers in cities, and should help businesses actually. Small batteries make it swappable. You can bring extra batteries, and it's only about approximately $5,000. This is an EV concept car called the Vision Avatar, after the movie Avatar, and it's made by Mercedes-Benz, but they haven't put it into production. It has a graphene battery technology which charges in 15 minutes and provides a 475-mile range, so this is amazing. The interior also is made of plastics from the ocean. They recycled them, so it helps solve sea level rising, and the graphene battery is totally recyclable. AVTR stands for Advanced Vehicle Transformation, and they use your heartbeat to start the car, and you don't need a steering wheel. It's pretty amazing. Here are examples of solar-powered vehicles. Lightyear 1 has a 450-mile range, but extends it with solar cells. Aptera goes up to 1,000 miles and still extends with solar cells. Scion also uses solar cells on not just the roof but on the body, and has bidirectional charging. Aptera is a three-wheeled solar-powered car, and with varying batteries you can have a range up to 1,000 miles. So the price is affordable, like about $30,000 to $50,000, and you can extend it also with the solar cells on the roof. It's a very unique vehicle. Lightyear 1, four-wheeled, solar-powered, has EV range of 450, but extends that with solar cells on the roof, or an outlet, and it runs approximately 170,000. Scion is a 5-door family size that has bidirectional charging, which means you can even charge your house, vehicle to grid, and vehicle to home. And 35-minute charging, 30,000 estimate cost. Summary: solar power vehicles do seem to be critical in reversing climate change. This is because you can have conversion and retrofit, which would use current ICE vehicles, so that would be expedited. New solar vehicles will provide greater acceptance and reduce range anxiety, and reduction of conflict, because you'll have greater security, is definitely going to occur. Okay, so here we are at evidence. What evidence do we have so far, and what additional data may we need? EVs are considered a best solution. Solar added to EVs expedite the solution. Advances of solar also expedite the solution. Research, we need more research in CO2 destruction of concrete parking structures, as in the Miami condos, to prevent that type of conflict. And we need more research on solar hybrids. So what are the main points in the speculation on the future research? Okay, number one, solar vehicles do solve range issues. Solar vehicles can expedite the solution to reducing emissions. Advances of solar vehicles will help expedite the solution. Educating the public is important. The government might hinder by not supporting it enough. Wars such as in Ukraine highlight the proper mentality. Solar energy solutions can provide the security and reduce conflict. And since all vehicles have magnets to some degree, new technology, new solutions will also provide future documentation of the benefits of solar vehicles. Limitations. Limitations include that competing technologies are proprietary, so it's difficult to get research information. Some reviewers said they actually had to buy the vehicle, take it apart, figure out how it works, and put it back together again. That's difficult. COVID caused delays and inaccessibility. Rapid advances are a problem because you're always a little bit behind. New things are coming, but that's also good. But it's a limitation. Educating the public is difficult. Government removes the funding or support, makes it difficult. Wars, especially, let's say, in the war in Ukraine and Russia, changes the world situation and makes research difficult. Natural disasters, for example, the Miami condo collapse makes research difficult because it changes people's ideas. The new research needs to be done. And then there's magnets and new tech and new solutions. So research can be very complicated and complex. Here's a little chart timeline that shows that in the 1900s, the first electric car was produced. And in the 2000s, we have Lightyear 1, Aptera, and Scion. So we do have available solar vehicles to help the solution right now. So what are people saying? What is public opinion? Some people say we need to drive less. Another survey shows that there's skepticism that there is global warming. And then some people believe that solar geoengineering is our only hope to reverse climate change. There are a few more opinions. Jay Leno feels that electric cars have not proven to be masculine enough, and that's part of the problem of why they're not being accepted as quickly as they could be. The video shows that opinion at 340. Elon Musk had previously had the opinion that the least efficient place to put solar is on a car, but currently Tesla and Elon Musk have introduced a Cybertruck and mentioned solar panels to extend the range, so I think he's kind of changed his opinion there. And the Mercedes-Benz Vision Avatar concept car uses some new technology which might be competitive, graphene technology, and it's a totally sustainable battery and fully compostable and recyclable, and fabric from ocean waste plastic is being used to help reduce sea level rising. So we have an interesting future, and opinion is that sounds great. So additional comments of what people are saying included students at universities. They're joining in solar challenge races. George Mason University has a solar 3D printed race car, and you can join that organization at George Mason or donate to it at hypernovasolar.org. Stanford their solar race car caught on fire, but students are still eager to improve and continue racing solar cars. So I think there is definitely a future for solar cars. Okay, conclusion. Solar vehicles can definitely solve emissions, and they're a critical element in the solution. Public opinion is positive, but still confused. If the gaps in geopolitics are overcome, and solar vehicles will then achieve production on a large enough scale, that will be the solution. There is hope for reducing CO2 and disastrous conflict and maintaining security. IT security, conflict resolution, and energy in the interdisciplinary sources is a solution. This is the end. Thank you for listening to this presentation. These are the references that were used in preparing this presentation.